Okay. So in the last class, I was telling you about CPU. Okay. So what is the definition for CPU? It is Central Processing Unit. Good afternoon, every one of you. Respond me in the chat boxes. In the last class, I told you what is CPU. Definition of CPU is Central Processing Unit. Similarly, I told you about primary memory. Okay. I told you about primary memory, secondary memory. I told you about ports. I told you about connections. I told you about input devices like keyboards. Okay. Again, mouse, variants of mouse. Next, I told you about output devices like monitors, CRT monitors. Similarly, network. Okay. What is the definition of network? It's a connection of computers. Similarly, network hardware. Okay, network hardware. So I told you about what is hub, what is repeaters, what is switch, what is routers. Okay, these kind of things. Say, let me show you, let me show you. Please type me any of the port of your selected one, at least one, every one of you. Everybody. Good, Sukrut. Ethernet port. Sukrut says Ethernet port. Okay. Kokila says audio port. You see there? We are having the different ports. The top one is serial port. Okay. Similarly, he will be having display port. Similarly, USB ports. Okay. Where we are placing our pen drives or all the cables. Okay. Similarly, Ethernet port, we can connect this one to the network. Similarly, SDMI port. Similarly, we'll be having power port. Okay, this will supply the. This is the power supply. This is the one for power supply. Okay, this is about the ports. Similarly, when we talk about the network devices, images of hub. Okay, routers. I'm taking the full advantage of the internet. Okay. You see there, these are the different network devices. These are the network devices. Okay. Please type me, everybody, any one of these things. Okay, these are network devices. I told you about repeater. I told you about switch. I told you about router, bridge, and gateway. Okay. Please type me any one of them. Okay, hub. Okay, Sukrut says, Vivek says hub. Okay, Tariq says router. Okay, you see there, modem. Okay, everybody will be having this portable modem for internet. Similarly, this is a network interface card. This card is known as network interface card. NIC stands for network interface card. Okay, then repeater, it energizes the signal. It energizes the signal. Let me allow in for few of them still. You see there, NIC stands for network interface card. Okay, please type me everybody network interface card. Network interface card, everybody. Okay, let me network interface card. Okay, all the people, please. Network interface card. Do you see there? It is network interface card. Similarly, next we'll be having repeater. Okay, signals will be weakened after the traveling for few distance. It will be energized by using, they'll get the new energy by using repeaters. They will travel more distance. Next we'll be having hub, where we'll be connecting multiple devices, multiple systems. It may be multiple printers, okay, or multiple other devices. We may connect input or output or servers. We may connect to the hub. Okay, now the switch. Okay, we'll be having switch. They'll be working in different types of networks. Routers, they'll also be working in different types of networks. Local area network, we'll be having local area network, wide area network, metropolitan area networks, like that. Okay, now the next thing is bridge. They'll be working in same kind of network, LAN and LAN. They connect to LANs, local area networks. Next we'll be having gateways. Okay, they connect geographically. Okay, they connect geographically distant networks. Okay, now just this is about a brief introduction. No need to go in deeper, just you must know how they look like. Say if you select any other devices. Let me show you the images, it's enough. You see there, hub. Okay, this will be the image for hub. We will represent this diagram for hub. Okay, an arrow mark. Similarly gateway. Okay, we'll be having gateway. Similarly routers. Okay, they may look like a small rectangular boxes. Okay, they'll be very wide. They'll be represented by using this symbol, routers. Okay, similarly repeaters, we'll be having repeaters, this thing. Okay, they will be represented by using this diagram in the networks. Similarly bridge, these are bridges, these are represented by using this symbol. Similarly switches, okay, they will be represented by using this symbol. Okay, these are in networks, how they are represented. So these are the network devices. Now the next thing is, I told you about different connections. Similarly, okay, hub, repeater, switch, and routers. Now the next thing is network types. We'll be having network types. Say we can categorize them as LAN, local area networks. Okay, LAN, WAN. Okay, similarly MAN. Okay, or MAN. LAN, WAN, and MAN. I'll give you a brief introduction about local area network, metropolitan area network, wide area networks. Next, we'll be learning network topology in today's class. Network topology. Whenever we talk about topology, it is arrangement of systems. We'll be having bus topology. We'll be having mesh topology. Okay, we'll be having ring topology. Okay, like this. Next, You'll be learning software basics. You'll be learning software basics, the definition of software, and different types of softwares like application software, system softwares, like this. Next, I'll give you the brief introduction of the C language, what it is, who has invented the C language, what kind of language it is. After that, the structure of the C program. Next, how to execute a C program. Then I'll give some dissection about the program. What are variables? What is constant? What is operators? What is expressions? If possible in today's class. Okay. So when it comes to LAN, okay, when it comes to LAN, LAN stands for LAN. Okay. Can anyone expand what is LAN? Can anyone expand what is LAN? Type in the chat.
Local area
Local
network.
area network.
Local area networks. Okay. LAN stands for is a type of it is a type of network. It is a type of network. See the definition, how you must define the thing. It's a type of network where where the systems will be in in between in between 10 to 100, 10 to 100. Okay, 10 to 100. They will be they will be fixed. They will be fixed, or they will be limited to a building. They will be limited to a building. Okay, this type of network will be limited to building. Okay, so this is the example for local area network. Now similarly, when it comes to metropolitan area network, MAN stands for metropolitan metropolitan area network. Okay, now when it comes to metropolitan, what do you mean by metropolitan city? What do you mean by metropolitan city? We'll be having people from different states. Okay, whenever the people are from different states, that kind of city will be known as metropolitan city. Can you tell me what is cosmopolitan city? Cosmopolitan, it's a city where the people will live from multiple countries. That kind of city is known as cosmopolitan. When it comes to metropolitan, okay, so it will be expanding into from metropolitan. It's a network where the systems will be where the systems will be from 100 to 1000, 100 to 1000. Okay, 100 to 1000. Similarly, they will be expanded, they will be limited, okay, or expanded to a city, okay, which spreads across which spreads across 40 kilometers, 40 kilometers in radius. Okay, in 40 kilometers in radius, that kind of network is known as metropolitan area network. Okay, similarly, it's not fixed. This number of systems is not fixed. Okay, but we take as a convention, we take the number of systems as a convention. Now the next kind of network is wide area network. It stands for wide area network. Okay, networks, these will be these networks will Please type me network topology, everybody. Is it audible? Is it visible? Okay, good, Nisarga. Everybody, please, network topology. Okay, good, Nisarga. Good, Tariq. Good, Hani. Good, Vishwa. Sukrut. Good, Swati. Good, Shuhas. Good, Yasashwini. Good, Vivek. Good, Abdul. Good, Tejas. Okay, network topology. Good, Kokila. Okay, now when it comes to network topology, it is an arrangement of systems. It is an arrangement of systems. Okay, we can arrange the systems in the buildings in different types. Okay, like a bus topology, like a bus topology, or we may arrange that one as a ring topology, as a ring, or we may arrange the systems as a mesh. Okay, or we may arrange as an hybrid. Okay, hybrid. Okay, hybrid, whenever we say it's a mixture of.
Sir, we can't see the screen, sir.
Okay, please let me know. Okay,
The notepad isn't visible, sir.
okay, okay, good. It was disconnected. So now do you
Yes,
see?
sir. Yes, sir.
Okay, good, thank you. See here, whenever we say network topology, the definition of network topology is, it is an arrangement. It is an arrangement of systems. Okay, in the network. In the network. Please, please mute yourself. Please mute yourself. Kokila, mute it. It is recorded. This thing is recorded. Okay. Now, so I was telling you about the definition of network topology. Network topology is nothing but an arrangement of systems in a network. They will be arranged as, they can be arranged as bus, they may be arranged as ring, they may be arranged as mesh, or they may be arranged as mixture of both the things. Mixture of above types. Above types. Okay. Now, let me show you some diagram just as a basics. You see there. Now we'll be having different types of networks. They are the backbones. They are the backbone structures. They are the backbone structures. Okay. Now, when it comes to the topology, it is the physical arrangement. It is the physical arrangements of the systems. There will be different shapes like bus, ring, and star. When we can even mix any of these things, that is known as hybrid topology. Okay. Now, when it comes to bus, the single cable connects all the systems. The single cable connects all the systems. Okay, all, and every device will be having equal responsibility for transmitting the data. Okay, and we'll be having something like terminators at the end. Okay, they are very inexpensive, they are less expensive. Okay, they are very easy to troubleshoot. Okay, what do you mean by troubleshoot? What do you mean by troubleshooting?
Solving the problem, sir.
Yes, in the network, there may be different kinds of problems. That is known as troubleshooting. Troubleshooting is very easy in this kind of topology. Okay, you see there, we are having systems connected directly to a bus. Okay, bus is nothing but a cable. Okay, that's why this arrangement is known as bus topology. Okay, now if this fails in some point, it is very difficult to transmit. That is one of the disadvantage. Okay, because it is directly connected. It is directly connected. You'll be having some devices like terminators. Okay, so here you must focus on how they are connected, how they transmit the data from one system to another system. Okay, it needs to travel the entire path. Okay, but before that you must know what is bus. Bus is nothing but a wire. Okay, bus is nothing but a wire. Okay, now advantages and disadvantages of this kind of network. Say they are very small networks. They are very small networks which will be ranging from 10 to 100 systems. Similarly, they are inexpensive as compared to other types of networks. Okay, other kind of arrangements. Now, easy to add another system. It is very easy to add one more system. Directly bringing a cable and adding at the end. Okay. Similarly, disadvantages. Maintenance costs can be high. Okay, if something failure occurs, we need to completely rearrange the things. Okay, that may be the disadvantage. Similarly, it is a congestion. Okay, congestion. Network traffic may be more if everybody wants to send the data at same time. Okay, if these two systems want to transmit the data at the same time, they can't use the same link. Okay, that is known as network traffic. How the traffic will be there on the roads. Okay, many people want to cross the roads at the same time. Okay, that is known as network congestion. Similarly, the other kind of arrangement is known as ring topology. This is known as ring topology. You see there, they are connected to a central hub. We can place a hub here. All the things will be connected to a hub. If this system wants to transmit a data to the another system, it needs to travel through the hub. Okay, so this is known as ring system because it may appear like a ring. Now, here we can see the connection between the neighbors. Okay, this system is connected to the neighbors. Okay, every system will be having two neighbors. Okay, that kind of topology is known as ring topology. So here what we do is we are using something like token passing. If you want to use this network, we need to get a token. Then only we can transmit the data, or this system may transmit the data. Okay. The advantages is it is easier to manage. It is easier to manage. Okay. It is easier for transmitting signals for long distances. Okay. Similarly, for high volume network traffic, if the network traffic is more means we can easily transmit. Similarly, enables reliable communication. Okay. What do you mean by reliability? Any one of you? What do you mean by reliability? Definitely the data is transmitted. Definitely the data is transmitted. No failure of networks. No failure of networks. Okay. That kind of topology is known as network ring topology. The next topology is star topology. Okay. This is known as the star topology. Let me show you that. Star topology. Okay, here it is connected to the central hub. It needs to pass through all the things. You can see in this diagram, it is central connected to any of the central device. Now it is connected. Say a single cable connects only two devices. Okay, a cable can connect only two devices. Similarly, it requires more cabling. Similarly, it can be easily moved or isolated. Okay, it it supports a lot of addressability. Okay, whenever we say addressability, it is the naming of the systems in the network. Okay, we say the systems as nodes. We say the computers in the network as nodes. Okay. Now, advantages and disadvantages. It is good for modern networks, very low startup costs, easy to manage. Okay, offer opportunities for expansion. We can easily expand. Okay, and disadvantages is single point of failure can cause the network to be shut down. Okay, or it may slow down like this. This is the disadvantage of the star topology. Now, when we mix two or three, okay, when we mix the two or three types of networks, they are known as hybrid topology. Okay, we may mix bus and ring, or we may mix ring and mesh. Okay, ring and mesh. Okay, when we talk about mesh, every system is connected to all other systems. Okay, let me show you that mesh topology. Just I'm getting you a diagram from internet. Okay, mesh topology diagram. You see there The mesh topology. Here, how many systems are there? Please respond me. How many systems are there?
5, sir.
5 systems. You see there, every one system will be connected to all other systems. You see there, we are having connection from here to here, and from this system to this system, and from here to this system, from this system to this system. This is known as mesh topology. Every system is connected to all other systems in the network. Okay, so this is known as mesh topology. It is also having advantages and disadvantages. Okay, every network will be having its own advantage and its own disadvantages. Okay, this is star topology, as I mentioned you. This is bus topology, as I mentioned you. This is ring topology. Okay, similarly hybrid topology. Okay, which are the two types of topologies mixed here? Which are the two topologies mixed here?
Hub and hybrid.
See, this topology is star topology. Okay, this topology is ring topology. Okay, so it is a mixture of ring topology and star topology. That's why it is known as hybrid topology. Okay, it's a mixture of ring and star. Okay, it is also having advantages and disadvantages. Okay, now the next topic is software. Okay, software industry, software. Say software. What may be the definition of software? Any one of you?
Programs used by the computer.
Okay, say it's a programs. It's a programs. Say, I'll put it in a very simple way. Collection of programs is known as software. Collection of programs is known as software. Now, what is program? What is program? Collection of instructions. Collection of instructions. Okay. Collection of instructions is known as program. Now, similarly, what is instruction? What is instruction? Collection of commands. Collection of commands. Okay. Collection of commands is known as instruction. Now, when it comes to commands, commands. Okay, when it comes to command, it is when we say the command, it is a small instruction. It is a small instruction. It's a small instruction. Okay, now when it comes to the software, we'll be having two types of software. Okay, software will be of two types: application software and system software. Okay, system software. Now everybody type me application software and system software, please. Everybody type me application software and system software. Everybody type me application software. Good, good Tariq, good Vishwa, good Nisar, good Kokila, good Yashwini, good Suhas, good Sharona, good Vivek. Application software and system software. Please type me. Everybody. Kedar Joshi, please type me. Tarun, please type me that. Vishwa. Syed Aliya Bakshi, please. Application software and system software. Can anybody give me example for application software? Good Raghunath. Can anybody give me example for application software? We are using.
PowerPoint.
Yes. Okay. Application software. PPTs. PowerPoint is nothing but PPTs. Okay. Let me tell you. Railway reservation systems or railway reservation software. Okay. Similarly, we can find many softwares in the hospital. In the hospital, we'll be having some software. Okay. Hospital management software. Similarly, we'll be having uh, hotel management systems or hotel management softwares. Bank, in the bank we'll be having softwares. Okay, all those are examples for application softwares. Games. Okay, how many of you play games? Please respond me. How many of you play games in your mobiles? Okay, good. Abdul says Tarun plays. Others, everybody. Nisarga, he used to not play, but nowadays he's stopped it. Okay. Everybody plays the games. Games is the example for application software. Okay. Good, Tejas. Keep playing the games. Gaming industry is very big. Okay. Keep playing the games. Games are very important. Okay. Now, games is the example for application software. Now, when it comes to the system software, okay, can you give me example for system software? Can you give me example for system software? Apps is application software. Okay, Tariq, apps is calculator. It is an application. Application software performs a particular task. Okay.
Sir, our operating systems.
Yes, good. Operating systems. They interact with the hardware. Okay, they interact with the hardware. Okay, that kind of softwares are known as system softwares. Examples is operating systems. Can operating systems OS? I'll give you Windows. Okay, Linux, Unix, Ubuntu. Okay, Symbian. Okay, Android. This is mobile operating system. Android will be interacting with the mobile hardware. Okay. Similarly, Mac. These are the examples for operating systems. Please type me any one of the operating system. Everybody among these. Please type me any of the operating systems among these, the highlighted blue color one. Okay, good. Android, good. Tarun, Mac, good. Abdul, Ubuntu. Okay, Sukrut, Ubuntu. Kedar, Linux. Okay. Tejas, Windows. Okay. Sharona, Android. Good, Yashashwini, Windows. Okay, so these are the examples for operating systems. See, similarly, we'll be having different types of system softwares apart from operating systems. We'll be having loaders. Okay, we'll be having linkers. Okay, we'll be having compilers. Okay, all these things. These are the examples for system software. Okay, please type me any of these three, or if you are interested, type me all three. Everybody, all three: loaders, linkers, and compilers. They are similar to operating systems. Loaders, linkers, and compilers. Everybody. Okay, all. Okay, linkers, loaders, compilers. Linkers, Sharona, good. Tarun Vishwa, type it. Tejas, good. Good Suhas, good Vishwa. Okay. Now these are also examples for system software. Okay. Compilers. See here, whenever we talk about loaders, they will be loading the things to the CPU. Whatever the program we write, these software will load that one to the memory. Linkers, they link two or three softwares. Okay. Compilers, they compile the programs. Compilers, what they do, they compile the programs. Every language will be having its own compilers. Can you type me any one of your computer language? Everybody, all 26 people, type me any of the computer known language. Java, okay, good. Abdul, good. Suhas, Python. Suhas says Python. Kedar says Java, okay. Vivek, C++. Kedar, Tejas, okay. Tejas, Tarun, Python. Kedar Joshi, Perl, okay. Kokila, Python, good. Tejas, C++. Yashashwini, okay, good. Good. Okay, Raghunath says Java. Good. You see there, all the languages, whatever you said, say C. Okay. C++. I will type whatever the languages I know. C++, Java, okay, Python, small talk, okay. Similarly, R language, Ruby, Ruby with Python, Ruby with Rails. Similarly, we'll be having uh, JavaScript. Okay. Similarly, we are having thousands of languages, thousands of computer languages. Um Perl, HTML, okay, PHP, okay, like this. These are the examples for languages. Every language will be having its own compiler. Okay. So every languages will be having linkers. Every language will be having loaders. Okay, that is the thing. Okay. Now the next topic is overview of C. Overview of C. Now, whenever we say language, why do we need language? Why do we need computer languages? You can speak if you want. Why do we need computer languages? You can unmute and you can speak.
For fast and easy programming, like for time saving and all.
Okay, I can put it in very simple way. Computer
Sir, it
languages,
makes computing easier.
yes, good. See here, at the very basic thing, okay. Languages are for communication. Okay. Why we are speaking Kannada or Telugu or Hindi? Why we are speaking them? For communicating. Now here the computer language is to communicate with the computer. Okay. Now the C language. The C language is is to communicate with computer. Okay. It was invented by Dennis Ritchie. Okay, Dennis Ritchie is the person who has invented the C language. It is known as a high level language. Okay, because we'll be using English like commands. Okay. So it is known as high level language. There are similarly, we'll be having different kinds of languages like low level language, okay, or low level language, or machine level language, okay, where we'll be having machine level language. They'll be having instructions in instructions will be like this: subtract, add, okay, they are like small simple instructions. But here we are using some English kind of things, but here we'll be using some English kind of things like print, okay, like scan, okay, these kind of things, okay, that makes the difference. So again we'll be having some mid-level languages also, but here you must focus on the C is an high level language, okay. Now these are the few of the features of the C language, okay. Features, we can say them as features, or the properties, of this language. Now it's also known as structured programming language. It's also known as structured programming language, okay. We'll be having different kinds of languages like structured, object oriented, okay, procedural, these kind of things, okay. But the C is a structured oriented language, okay. Whenever we say the structure oriented language, we are focusing on the functions. Whenever we write something, we focus on the functions, okay. Now that's about the overview of the C language, okay. Now the structure of the C program, how it may look like, okay. How we must write, okay. First we'll be having header files, okay. Example, I may give you like hash include stdio.h, this is one of the example, okay. Header file, first we must write header files. Next we must write global declarations, okay. We may using some variables like int a, okay, or b, okay. We need to declare them. That kind of declarations is known as global declarations. Next, function declarations, okay. Similarly, we may have above the header files, we'll be having something like comments, okay. They are for information, who is the author, okay. Who is the author of the program, what is the use of that program, date of when it has been written, okay. All those things. Comments is optional, Similarly, functional declarations, okay. If I'm writing any program or any function, we may be using like this: a comma b. We'll be giving semicolon, okay. Now after this, we are writing the program in the main. We are writing the entire program in the main, okay. Now this is the body of the main. This is the body of main program. Here we'll be having statements. Okay. Here we'll be having statements. Whenever we say statements, they are instructions, okay. So this is the structure of the C program, okay. Now there are 5 parts: comments, header files, global declarations, function declarations, and the main, and the body of the program, Please type me any of these things. Okay, or all of these things, all of these parts. Everybody. Structure of C program. You see this: comments, header files, global declarations, function declarations, and the main. Please type me this, everybody. You take 2 minutes time and try to type it. Okay, good. Comments, header files, global declarations. Let me open the chapter. Comments, header files, global declarations, function declarations, body of the main. Good. Good, Kokila. Good, Vaishnavi. Okay. We can stop here. In the next class. Good, good, everybody. In the next class, I'll show you how to write a program, how we are going to execute that. So, in this class, you learned network types, you learned the network types, you learned the network topologies, advantages and disadvantages. Next, you learned what is software, okay, different types of software, okay. After that, the languages and the overview of C language and the structure of C program okay. In the next class, I'll show you how to execute the programs. Okay. Thank you, every one of you. You can leave the class.
Thank you, sir.
Okay.
Thank you, sir.
Okay.
Thank you, sir.